Hey, what's up everybody? Welcome back to another Layer by Layer. In today's tutorial, we're going to take a look at the all-new Adafruit PyBadge. This is it right here. This is running MakeCode Arcade. It is a dev board that's designed for programming games. So let's take a look at it now. If you take a look at the product website that's linked down in the description and in the card, you can see the two different versions that we have. We have a low-cost version and a fully featured version. Check those out. This has built-in accelerometer, LEDs, display, speaker, audio amplifier, USB recharge, so much stuff. Check out the product page and be sure to sign up to get notified when these are back in stock. The main thing I wanted to talk about it though is MakeCode Arcade, which is from Microsoft. It's open source and it is an amazing block-based editor that you can create and develop games for this hardware, which is awesome. There are a number of different games that are already in as tutorials and example games. You can just come in here and learn. If you don't know any programming, this is going to be really helpful for folks that are just getting started. So I'm going to open this example, and this loads in a drag and drop based editor where it is fully editable. It is awesome. They have a sprite editor where you can edit sprites and you can play these. This exact game that I was just playing is running in the simulator here. So even if you don't have hardware, you can still develop some awesome games. So jumping back over to the screen here, I will show you a quick demo of this in action. This is the PyBadge. It is about the size of a credit card and as thin as a deck of cards. This thing is amazing. So you're able to play some really fun games that you might be familiar with. This is kind of like a Flappy Bird clone. And you can see it's got like particle effects, it's got animations, sound is coming soon, and we will also have hardware support for these NeoPixels so that you can do all sorts of bedazzling effects. So that is really awesome. I'm doing pretty good actually. And like I said, this game is completely editable. If I wanted it so that I couldn't die anymore, well, then we can totally do that. But in this tutorial, we're going to take a look at the case and talk about how to design it in Fusion 360. Excellent. So let's take a look at that in Fusion 360. But first, let's talk about the 3D printed case. So this is 3D printed and it has a really nice notch at the top here that allows access for the USB port and the little on-off switch. It is printed in transparent material, so that's why you can see through it. You can see the lovely silkscreen artwork designed by Philip Burgess. This thing is awesome. On the back here, it's also transparent, but it's a little bit darker, so you can't really see all the components, but you can see the batteries over here, speakers over there. There's a reset button that's over here that's interesting. It's sort of concaved and it's kind of going inward, so you do have to kind of press it down like this in order to reset. But the cool thing about that is that it is you can't push it on the flat surface and accidentally press the reset button. That won't happen. So that was a little design thing that we needed to do there. Another noticeable thing is that there are these kind of chamfers on the edges of the case. And what are those about? Well, they kind of do two things. First thing is that they kind of indicate where the Snapfit features are. The second thing is that they kind of help you open this case when you want to open it. So the way to open it is you get your thumb here, your fingernail, and then you get another finger on a different side. So when you clink those together, that unclamps it. Now we can take this back off, and you can see that comes off there. There is our little reset button. All that it is just a little flange and a little cylinder that comes out there. The edge here has a kind of an extruded, tapered edge here, so that you can actually get your finger in there when it's installed. Cool. So that's the bottom and the little reset button. There's also 4 standoffs here. You notice the standoffs do not have any holes in them because we're not using any screws. Looking at the front plates, the front plate has all the proper cutouts for the buttons, the screen bezel, and those NeoPixels that are at the bottom there. I'm just trying to get this out here without too much force. It should just come out, but you'll see that the features here kind of keep it a little bit in place there. So there it is. It's free from its cage, and now you have a good look at this. So the way this works is that it is thin. It is about 5 layers thick. That makes it about 1 millimeter thin, and that gives the case flexibility. So you can see that it can flex like that. These catchers here, the things that catch the nubs, they are pretty rigid and they don't flex much. What's actually flexing is the case itself. So if you look at the bottom case, well, that has the same type of flex to it because it's the same thickness, right? These edges here are about 1.5 millimeters thick, so they are all perimeter and not really much infill. So when we connect these two together, the Snapfit features are what keep this thing rigid. There's no play in this, and there's no gaps in between this. They are very, very much clamped together. The only way to open this is to get your fingernails in there and to pry it open like that, which works out pretty well because you don't have to use like a tool or something. You can just use your fingernails if you have them. So that is the two-piece case. No hardware screws required. So how does that work, right? Well, when you rest this on, let's put the reset button back. When you rest the PCB on top of the standoffs, there's a little bit of a leeway here for this thing to move around because there's clearance between the edge of the PCB and the edge of the case. That is for these snap fitted features. The cutouts are what keep the components locked in place. So once these snap fits are clamped down, there's nowhere for these components to go, for the PCB to go, because it's pretty much registered and locked in there with these cutouts. So that's the way that is working. So this is a really awesome snap fit case that can be used in a lot of different projects. I've been using it on just about every project that I create. So in this tutorial, we're going to take a look at how to create this case for the PyBadge. So we put together a 3D model of the PyBadge using EagleCAD and Fusion 360. The files are available to download. Links are in the description. I have a couple of tutorials as well up here in the card that will show you how to put together an EagleCAD PCB, bring it into Fusion, and map components to it. We also have an STL file if you guys want to use Tinkercad or something like that. We have different file formats, so you guys can use them in your CAD package, not just Fusion 360. Jumping into Fusion 360, I have a blank document already created. This is going to speed this up so I can bring the PyBadge in as an external component. So as the external component, you will see that it has a little animation to it if you're using the Fusion 360 file, and it should have a one-to-one accurate representation of all the models in the physical hardware. So we got to bring this into this document. Before we do so, let's think about the structure of our document. The first thing I want to do is create components. That's what I like to do. I have a hotkey, the letter N, for creating new components because I create so many of them. Let's call this one case. Inside of case, let's make two more. Since this is a two-piece enclosure, we need a top, create another one, and a bottom. Not going to create another one. With this parent, the parent should be this one. And then this will say bottom. Will that work? Yeah, it did. Excellent. Sweet. So now I'll go back to the active component and then back to the active component of the root level. So now where should we bring in our PyBadge? For me, I like to have it in the root of the document so I can always access it easier without having to drill into a folder. Insert into current document, and that'll bring it in. It's going to bring it in this orientation. I'm just going to leave that orientation alone because I'm going to apply a joint to set this down. Now, I don't have anything created yet. You don't really need to. You can use a joint to apply it to an origin. So if I bring out the origin, you can see we have our construction planes that we can play with that are default to this main document. So with the origins turned off, I can get a better look at the PCB. Down over here in the center somewhere is where it's going to be. So I'll hit the letter J as the hotkey for joint. And as I roll over on this, we'll see a little triangle. I want to select that triangle. It kind of snaps in there. I'll click that. Now it's automatically selecting component 2, which will be not an actual object or a component, but an origin. So if we hide the PyBadge, we can get a better look at our origin. I will roll over that center dot, the white one, and you'll see that it's kind of oriented flat with the plane, and that's what I want. So I'll click that. I have to bring back the little light bulb to see it, and then I should hit OK because all the components will go with it. And now it's in the exact spot. It's basically 0, 0 with the floor plane, and that's going to help us a lot easier when we create some construction planes. All right, so looking at the case now, the first thing I want to do is activate that component. I'm going to create this kind of global sketch that both the top and the bottom component can use. So I'll be sketching in this one for our main component. So what I'll do first, or at least next, is a construction plane. We'll make an offset plane. I'm going to select this bottom here. I can't get to it so easily enough. I can just turn off the PyBadge, select that bottom floor plane. I want it to go down a bit, so I'm going to bring it down about -8 millimeters, and I'll hit OK. That way it's 8 millimeters away from the bottom of the PCB, and it'll be the bottom of our case. So that's how much room we'll have, and that's going to accommodate for things like the battery and the speaker. So with that construction plane now, I will go ahead and think about what component should be active. The top case shouldn't be active, it's the bottom, because I'm going to work on the bottom next. So with that selected, now I can select that construction plane and create a new sketch. So that's the new sketch. Let's bring back the PyBadge. The main thing that I'm going to bring in here for this sketch is just the mounting holes. So that's going to be these guys here. I'm going to bring those in as a projection. One thing we should know, if we click on our name up here at the top right, and we click on preferences and then go to design, this little sub tab, there's this option here called auto project geometry on active sketch plane. I personally like to have that turned off, and what that does is whenever you sketch on another surface, it'll bring in all the edges from that surface and project them automatically for you. I don't tend to do that a lot. I don't need all the edges, so that's why I have it turned off. But if you like to have that feature, you have the freedom to turn it on or off as you like. But as behavioral wise, what will happen is when I sketch on an existing surface, there won't be anything here yet because I'll have to bring it in manually, which is I'm about to do. So I'll hit the OK button. I'm going to bring in this guy here and this guy here. I use the letter P, which is the hotkey for projection, and I'm just going to bring in these 4 edges. It could be either the top or the bottom as long as it's one of these circles. So I'll hit OK. So with those circles in there now, I can turn off the PyBadge to get a better look at just those mounting holes. Next thing I'm going to do is use the rectangle tool, and I'm just going to go corner to corner here. So I'm going to go here and then all the way down over here to here. Now what I want to do is I'm going to bring up my user parameter window. I have a hotkey for that because I open it so much, and I have the hotkey letter U, and that's the one I picked. So I'm going to create a new user parameter. I'm going to call this padding, and I'm going to give it a value of 9 and hit OK. I'll create another one. Let's call this one gap. This is going to be like our clearance or tolerance between edges that are mating. This is going to be 0.4 millimeters. Let's see, what's another good one? Shell, that's another good one. I'll put my favorite thickness of a shell, 1.5, I'll hit OK. And then I have a top and bottom surface, so I'll just call that thickness, and I'll label that, I'll give that a 1 millimeter thickness. There's some other things I might come in here, but I can always come in here and edit it. So I'll hit the letter U. Well, actually the letter U doesn't close it. Interesting, you have to hit the OK button. The letter U brings it up though. All right, cool. Let's start applying some dimensions to this because none of this is locked in yet. These holes, however, are locked in because now if we ever move our PCB, well, these edges will go with it. So let's go ahead and start up here, and I'll create a dimension. I'll say I want this edge to be a certain distance away from this center circle, and I'll use that padding user parameter that we created. I'll do the same thing for the opposite edge here, line edge. Say padding. Let's go in the opposite corner down here, and let's kind of move these in a little bit before applying that sketch dimension just to make it easier. So now sketch dimension tool, edge to circle, padding, opposite edge to circle, padding. And now that we have those 2 opposite corners, we don't have to worry about these corners because it's already constrained for us. Nice. So I'll hit finish sketch because we're not done with it. Let's go back into the sketch, sorry. Next thing I want to do is create an offset on these mounting holes. So I'm going to hit the letter O for offset and click that, and it gives me a 1 millimeter. You know what? I already have a thickness, and if I ever want to change it, I could just change the thickness value instead of having to come in here and change all the circles. So let's do it again. The letter O for offset, click on our circle, and then type in thickness, enter. Let's do that for this one. Thickness, enter this one over here. O, click, thickness, enter. Excellent, so now we have that. Now I'm done with the sketch for now, right? So I hit OK. Now with the bottom selected, interesting. You can see I have the sketch created in that bottom. I should have put it in the case, which I can move, easy enough. Excellent. Let me go to the main component and you can see, yeah, that seems to work. You can totally drag him in and out of that. So let me undo that and leave it there. That looks fine. Okay, that's just thinking out loud that you can indeed move sketches from one place to the other without creating a new feature in the timeline. That's very useful, folks. Keep that in mind. All right, so now I have it in the main root. I don't need it in the main root, so I'm going to bring it back over here into the bottom, and you can see, oh man, that's great. I don't know if that's a new feature, but I really like that you can do that. All right, maybe you could have done it this whole time. So let's make sure that the bottom is an active component because that's what we're going to work on, the bottom. I'll hit E on my keyboard to extrude and just select this whole guy here. Now I need to go downwards, so it's going to be a negative value, and then I'll type in that user parameter thickness because I want it to be 1 millimeter thick. All right, and then if I bring back the PyBadge, let's double check our work and make sure that indeed we have 8 millimeters of a distance between this surface and the bottom of our PCB. Minimum distance, 8 millimeters, excellent. And we can always change that because that is tied to our offset plane over here. So if we ever need to add more room, maybe we had a bigger, thicker battery that's 12 millimeters, just type that in and you'll see that our body now moves down with it because it is following that chain of events. So it's looking good. Come back over here. Wait, actually it's not a parameter. So what should we call it? Would you call it bottom distance with a camel case? And that was 8 millimeters, right? Hit OK. So now when I come into this here, I can say negative bottom distance. And then I'll go back to 8 because now we can change it as a user parameter. And that's a good little exercise there on how to take an existing value and turn it into that. It's not hard at all. Just go in there and edit it. Excellent. So with that, now I want to create another extrusion. Again, I want to make sure I'm in the right spot. Bottom, activate component. Let's turn on that sketch. I'm going to bring up the extrude tool, the letter E, and just click these circles here. So it's going to be these 8 circles, the inner one and the offset. So that gives us 8 profiles to select. Almost there. This one and this one. Cool. Now that we can, now that we have that, we can basically just type in the distance, the bottom distance, because that's basically the same, right? So hit OK, and that gives us that. So now that'll update whenever we change the bottom distance if we need to. Like I said, bigger battery, bigger speaker, that might be it. All right, I just turned the sketch off, just kind of look at it. And the next thing I'll do is create another user parameter. I want to be able to change the fillet. I want to round these edges off there because they're really, really sharp. So let's go ahead and create a corners. Let's give it a 5 millimeter value. Hit OK, and now I'll create the fillet using the fillet tool. It's the letter F. So I'll click on these edges here. Select these 4 edges by kind of just rotating. I'm holding down. You don't have to hold down any key. Just append it by clicking on it. Excellent. And then I have those 4 selected. You can see 4 edges here. And then for the input box, I'm going to type in corners, enter, and there you go. Now that's a user parameter I can change. Sweet. Next thing I want to do is I need to create a shell, a wall for this guy here. Bottom is still selected. Excellent. I'll go ahead and create a new sketch and then click on that surface. If you had the auto project feature turned on, you would have had this automatically projected, but I don't. So I'll hit the letter P and then click on that thing. It's kind of a 2-step process for my situation, but again, I don't like to project things most of the time. But I am right now. Let's do an offset on this edge here to create that shell. So I'll hit the letter O, which is the hotkey, and then click that edge. Make sure that the chain selection is, well, selected so that it's kind of getting the whole loop. So as I manipulate this, you can see that whole chain is moving. Real good thing to note here is that with the fillet here, it's kind of adjusting the fillet. So although the fillet is 5, as I bring it in, it's kind of deducting that and smoothing that out so it's consistent. That's really nice. So I'll put negative shell because it needs to go on the inward. If it was positive, it'd be going on the outside like that. So I'll put that negative value there, negative shell. It's going on the inside. Excellent. So now that that is a profile that I can select, well, select it, hit the E key for extrude. Now I can bring this in. I don't know yet what I want to do here, how big it is. So I'm going to do something like 4, maybe 10. Maybe that looks fine. 10, maybe less than 10. I'm not sure yet. So let's go down to 5. Hit OK. Excellent. So we have that. All right. The next thing I want to do is create the top. I want to create the top because the main thing here is that let's create the top and the bottom. And then we'll create this notch here and cut through it before we create our Snapfit features. I think that's going to be helpful. So now I'll create the top here by selecting the top. We'll activate it. I don't have any sketches for the top yet. So because the bottom already has our fillet and our shell, why not just select that surface there and then hit the letter P. That'll create a sketch. It's not projected anything yet because I got to select the surface. So I'll select that surface. It sees it, I'll hit OK, and now I get my edges. Excellent. So I'll hit finish the sketch because that's kind of all I need there. If I bring back to the bottom, you'll see that the sketch is indeed inside the top. So I can now extrude that out. Let's make it 5 as well. It's going to be a new body. Hit OK. I need to get underneath there like this. So what I'll do is hide the bottom and then bring back the top sketch here. So now what I can do is I can, by looking at underneath it, I can select the inner piece of that offset and the outer piece of that offset. So I have those two profiles selected. Let's look at the top again. We want this to start not from the profile plane, but from an object. And I'm going to select this piece here to be that object. Next, I want to extrude upwards as I guess it's a negative value. So I'll keep that as a negative value. And instead of leaving it as a fixed value 1 millimeter, I'll change that to thickness, because that's the user parameter that we're using for the bottom. So that's the thickness. It's 1 millimeter as opposed to 1.5, which is the shell. Now we have that. Now, as we look at it, I'll turn the sketch off. As we look at it now, let's activate the whole document. And now we can see stuff without all the ghosting. I'll turn off the origin, and let's turn the bottom on. And now you can see we have this that's basically encompassing it all. I'd want to do a cross-section analysis so I can actually see inside the case. So we can do that by going under the inspect window and say, actually, not yet. Let's do a construction plane. There's this guy here called midplane. So that means let's just select that. And then I'll select this surface, rotate on the opposite end, and select the other opposite surface. And that gives me a midpoint in between those two surfaces. So hit OK. It's a little bit smaller, so I can click to drag it, make it bigger. Just those edges there. And now I can use that as my section analysis. So inspect, section analysis, and that'll cut through it. Hit OK. There's a little bit of a, I'm not sure if it's a bug or something, but just to note, any PCB components that have silkscreen graphics, the decals just won't obey the cross section. So you get this kind of weird looking thing. That's fine. We might be able to get a better fix there. But for now, we're able to see it. Sweet. Well, we are off to a really good start. This is going to take a little bit, but I wanted to really do this step by step so that you folks can be really aware of what can go wrong and what to look out for when working with these components and working with offsets and projections. So I want to leave it at there. In the next tutorial, we're going to create all the little cutouts in the Snapfit features, and we'll also create that notch for the USB cable for a USB port in our on and off switch. But that's going to be it for me. If you guys have any tips or any questions, please drop them in the comments. Thank you guys so much for watching. I'll see you guys in the next one. But until then, remember to make a great day. My name is Noah Ruiz. I'll see you guys next time. Bye, folks. And cut.